For some reason, the SAT really likes to test the concepts in this question. So this is a good review of a lot of different things and a lot of different ways of thinking about the SAT. So first and foremost, we have to be able to look at the system of equations and know exactly what kinds of equations we have. These are both lines. How do I know that? Well, I have an x and I have a y, two variables, and there are no exponents. There's no multiplication that could generate an exponent, okay? These are just going to be x to the first and y to the first, so they are very simple lines. So that's the first skill, being able to recognize when you have a line. Number two is knowing what you should do with a line, is we should probably convert it into y equals mx plus b. It's our safe place. It's where we want to get whenever a line looks confusing. There are things you can tell about lines when they're in other formats, but they're much harder and they're not as useful for what this specific question wants, the number of solutions, okay? So first and foremost, it's never, ever, ever going to be the case that two lines can have two solutions, okay? A solution, when we graph it, is a point of intersection. So it's impossible for two lines to have more than one point of intersection. And one of the things is not a line. If it's like a parabola where it curves, then yes, we can have more than two solutions, but at most, we're gonna have just one, or we could have none when they're parallel, or we could have infinitely many when they're just literally the exact same line. So that's really what we're deciding. And the way to think about all of those situations is to look at y equals mx plus b and see what kinds of similarities we have between the two equations. So let's convert. Let's start with the first one here. 3x plus 2y is 8. I would subtract the 3x and I would get 2y is equal to negative 3x plus 8, and then I would divide by 2, and I would get negative 3 halves x plus 4. So that is one of my two equations. For my other equation, I'm going to need to do a little distribution, but the process is largely the same. So in fact, actually, I'm not even going to bother with the distribution. I'm going to start by dividing both sides completely by 3 just to make that go away and make that easier. So x plus 2y is equal to 8/3. That fraction does not bother me. It's not going to end up mattering. I'm going to subtract x from both sides. 2y is equal to negative x plus 8/3, and then I'm going to divide by 2, which is going to make a little bit of a mess with the fraction. I don't really care about it, though. I have negative 1/2 x, and then 8/3 divided by 2 is 8/6, which is 4/3. I don't really care about that math. I might be wrong, but I don't really care because all I care about is the slopes. There are three things that could happen. If the slopes are the same and the y-intercepts are the same, then we have infinitely many solutions. And we can tell that these are different slopes and different y-intercepts, so no good, that one's wrong. We can also have, if we have the same slopes but different y-intercepts, so that's the m portion of y equals mx plus b, then we would have no solutions because the two lines would be parallel, they'd be moving in the same direction. That's not happening either. So that leaves us with just one option here. The system has exactly one solution. These are just two normal lines. They just kind of cross. I don't know where they cross. I don't care. They cross once like any normal system of lines. There's nothing special about this. They may look very similar at the start, but that is just a trap to lure you in. And that is why we always want to get back to y equals mx plus b, because that is the safe place where we understand the slope and the y-intercept the best. And that is how we're going to determine the number of solutions. So when in doubt, go back to y equals mx plus b. It is your safe place for lines.